Hello and welcome to today's Wired Briefing, the win-win of net zero computing. I'm Nick Compton, contributing editor at Wired UK. Information and communications technology consumes 2% of the world's energy. That demand is only going to increase, and data centers are under scrutiny for their outsized contribution to CO2 emissions. But there are ways to make data centers carbon neutral and even carbon negative, and we're going to talk through some of those strategies today. I'm delighted to be joined today by Scott Tease, the Vice President and General Manager of High Performance Computing and AI at Lenovo, who is going to outline some of those strategies for us. Scott has been with Lenovo since 2014, following the acquisition of IBM's System X team. Prior to this, he spent 14 years as a member of the IBM System X executive team. Scott, welcome. It's great to have you with us today.
Great to be joining you. Thanks for having me.
So maybe before we get into the kind of specifics of data centers, ESG metrics are kind of increasingly important for all businesses, and you're out in the world seeing businesses, talking to businesses. How are they? It's a big question. How are they responding to that challenge, and what are some of the initiatives within Lenovo to tackle those issues?
Yeah, Nick. So Lenovo is kind of unique. I mean, we serve a very wide variety of IT. For our customers, whether that IT fits in their pocket or on their desktop, or whether it's servers or storage that fit in their data center. We get a chance to see pretty much the full spectrum of what people are using out there. And no matter how wide or diverse it is, there's two things that I think most of our users have in common. One is they see IT as being the connection, the bridge between all of us. As the pandemic continues to keep us physically apart, everybody agrees it's the IT that's been the bridge to keep us connected with our friends and family, fellow employees all around the world. So that's goodness. The other thing we're seeing that most everybody agrees to is that sustainability is more important now than ever before. Our customers are looking to Lenovo as kind of a leader in this field. We started our journey over a decade ago, looking for ideas on what we can do to help them and how they can run their IT and buy their IT in a more sustainable fashion.
Great. And so, the pandemic has, if we're in any doubt, the pandemic has made clear how much we kind of need and rely on information technology and digital communications and increase that reliance. But that comes at a cost in terms of energy use. And can we just kind of outline how big a problem, IT and perhaps particularly data centers are in terms of CO2 emissions? I mean, people have an idea that it's not great, but can we put a figure on it? And then, how much worse it could be, kind of worst case scenario.
All this IT that we're buying today, it's the lifeblood of our businesses, right? It's what drives all the business value. It makes customers interacting with their suppliers and their vendors more enjoyable. So, that is the good part. The downside is all these devices, again, whether they're in your pocket, on your desk, or in the data center, they do consume power. The more you have, the more power you're going to consume. The connection between power consumption and sustainability may not be that apparent, but just know that the power that we use for these devices has to be generated somehow, somewhere. For most of us, that generation comes by burning fossil fuels. Not everybody around the world, but for most, at least a significant portion comes from the burning of fossil fuels. As we burn those fuels, CO2 is released in the environment. And that's where the CO2 or the emissions, the greenhouse gas emission issue comes from. So the key for me is the less power you use, the less power that needs to be generated, the less CO2 that you're going to impact on the environment.
And I mean, data centers, there's a kind of double hit with servers and data centers. I mean, they require a lot of energy to do their job. They put out a lot of energy as heat, and then you have to expend energy taking away that heat or doing something with it. But you believe, and you believe there are things we can do to get to net zero computing and even to carbon negative, which we'll get to later. But the first job is simply to understand how much power you're using and how you're using it, I guess, is the starting point.
Yeah, absolutely. Again, having a good baseline is the critical part of getting started on any journey, right? You got to know where you're at and you got to know where you're beginning from, and you start from there. Let me talk a little bit about the data center. So the data center is an interesting place. It's very, very dense. You talked about it early, and as you kicked us off today about being 2% of the world's power consumption. It's growing very, very quickly because we have so much dependence on our IT that continues to grow. The data centers are very densely packed. They're 50 times more power intensive per square foot or per square meter than a typical office space. And what really hurts us in the data center is the fact that every watt of power that we consume ends up in the room in the form of a watt of heat. It's the law of conservation of energy. Now, when that heat is created, we have to deal with it. We have to air condition it, we have to chill it. For many data centers, even the most energy efficient data centers, that could add a 40% additional power consumption just for running those chillers, those air conditioning. So the power really adds up quickly in the data center environment. And that's why it's a great place to start when you're looking at how you can get more energy efficient, how you can get more sustainable.
Okay. And so this is where I kind of get a little bit confused as well, just because there seem to be all kinds of ways of cooling computers or servers individually, and then all kinds of different ways of cooling data centers. What is the kind of most common setup you see in most businesses?
Well, so the way a server works and the way your PC at homes, or your workstation, your gaming platform, whatever it might be, works is the parts that are in there, like the memory, the processor, the hard drive, the network adapter, they all consume power, they all give off heat. Some of those components, like the processor, very dense amount of power, like a GPU, very dense amount of power being given off. I've got to move that heat away from that device before it overheats that part of the server, that part of the PC, what have you. To do that, traditionally we use air cooling. We have a lot of small fans in the device. Those fans consume power to turn, and they move air through the device, pulling that heat out with it. Now, once the heat is outside of the data center itself has to find a way to move that heat around to handle it. I can't just let it sit there, or it'll overheat and behind the rack and cause real problems. So again, traditional method is I use very large fans, very large air moving devices to move all that massive amount of air to somewhere else, into an air conditioning unit or a chiller unit. I try to cool it back down, and I will pump that now cold air back to the front, and this whole thing starts over and over again, and it goes on all day long. I chill the air, it goes through the server heats it up, the data center handles it, and then pumps it back in front. But again, it's a lot of power consumption at every step just to handle the heat being generated by those parts that bring us all the business value, like the processor, like the memory.
Okay, so I think if you break down and get into how the energy is used, you'll find that what kind of 2/3 is going towards the actual processing, and a third on the cooling, something like that.
Data center wide, Nick, that's not a bad, that's not a bad estimation. It's inside the device itself, inside a server. Typically if you ever walk into a data center, you'll see these devices. They're what we call 1U tall for the most part devices. They're all stacked really densely inside of these IT racks. They typically consume about 700 or 800 watts of power each. So that means every hour they're running, they're consuming about 700 or 800 watts. Of the power in that server, about 10% of it is going just for the fans alone. Now that's just to run the server. The bigger problem, as you talked about with that percentages you gave us, is after that heat's generated, the data center still has got to do its bit, which adds an additional 40%. So you're really only getting a much smaller percentage of power consumed for that real good business value than you probably would like to get. But for legacy data centers, that's the way it is run for a very long time.
Wow. So I guess the first job is just to make sure that the computing is as efficient as possible, that it's doing, in some ways, not the bare minimum, but it's doing what it needs to do in the most efficient way possible. And Lenovo, you've created software that kind of monitors the power being used and thermal output, but then also suggests ways to reduce energy use while also kind of maintaining the performance. So yeah, kind of doing what needs to be done without doing too much. Can you talk a little bit about how that software works?
If I could, Nick, I'd like to talk a little bit about the software and just the design in general.
Yeah.
So there's a lot of components that are inside the server that I myself and most data center operators and data scientists and engineers, they're kind of fine having those burn power. The processor is doing math, the memory is storing things, staging things, the network is moving things around. All those parts are like the backbone of the business value we get from IT today. There are a lot of other components that are in the server that if we designed it smarter, if we designed it in a better way, or we managed it better, I could take out a lot of power consumption without impacting the business value. That software that you talked about, we've got a couple of different types of software that we have developed here at Lenovo. Its entire goal is to maximize the amount of performance you get for every watt of power consumed. I'll give you a great example. Not every job that's routed in the data center needs the highest performance processor running at 100% of all the components. When a job is entered into a server, if there's components in that server that are not required for that job, our energy management software can turn those down, turn the frequencies down, turn components off, all in an effort to save power consumption when the devices are not fully needed. And that to me is a great example, because we're not impacting business value at all, but we're finding ways to drive out power consumption. And there are a lot of other examples like that, just in system design alone. Things like titanium power supplies. When we purchase a titanium power supply, we're going to save 2 to 3% on power consumption, just because it's a more energy efficient power supply than your traditional gold or say platinum power supplies.
I've got it. And then quickly back to the software. So, I mean, the software, it can do that automatically in terms of,
For the most part, yeah, for the most part. There's, you know, some of the tools need a little bit more information on the jobs, and they work in concert with some of our customers' other software. Some of it can be pre-programmed, and we can put servers into more energy efficient modes, things like that, that will really help tap down that power consumption whenever possible. It's a smarter way to unlock the power assets that are in the data center. Most of that energy efficiency software was really designed to make the most of limited infrastructure resources or power infrastructure that was in the data center. Now people are finding out that, man, that same software that minimized my power consumption because they didn't have enough power being fed to my racks, also has some really great sustainability benefits by, you know, helping me drive down power consumption. So multiple goodness benefits there that come with it.
No, exactly. I mean, as you said, you know, this is a win-win in that very simple sense that you're saving dollar spend. We know energy prices are going crazy, you know, so the business incentive is you know, is kind of double there. So going on to more innovation in terms of cooling and new thinking around alternative cooling methods. What's going on there? What's kind of coming on stream or is in the pipeline?
This is a fun area. I think this is a really fun area. But before we move there, you said something that I got to comment on.
Yeah.
And it's around the power, the cost for power. Most of the time when we think of sustainability or anything eco-friendly, all of a sudden what jumps to our mind is this concept that's going to cost me a lot of money. In this particular case, energy savings, power savings in your power bill, and sustainability, they all walk hand in hand. So it's really a beautiful thing. I just had a comment on that when you brought it up. I thought it was a really good point. Now, moving on to the liquid cooling side. Now, some of our customers around the globe, they are at the cutting edge of the highest performance GPUs, the highest performance processors. And what they found is that to keep up with that from a traditional air conditioning approach just was not viable. So they started looking at liquid cooling these components and liquid cooling these servers because it was a better way to unlock that performance and a better way, a more energy efficient way to run those servers. We're starting to see our liquid cooling, we call it Lenovo Neptune. It's our brand for all of our liquid cooling innovation. We're starting to see that show up literally all over the world. And a big part of our new renaissance of this new interest in liquid cooling is all around sustainability, because it is so much more efficient to cool a device with liquid than it is with air. Okay, great. And so in that, by some of the efficiencies and the software that can monitoring how energy is being used, and by adoption of liquid cooling, can that alone get us to a kind of carbon neutral situation? Yeah, so here's the way we step through this with clients. You mentioned it earlier. The first thing you got to do is you got to baseline. Once you baseline your power consumption and your power options, you find out where's your power coming from, how is it being generated, what is the carbon emissions required to generate your power. We can then look at ways to do two things. First, drive out wasted energy, get more energy efficient. Installing the energy software is a couple %, moving to these high efficiency power supplies like the titanium power supplies is another. Looking at very interesting heat sink technologies that can reduce my fan power is another. You start adding up all these 2 to 3 to 4% here and there, and all of a sudden you've got 10 to 15% of savings on your power bill because you've reduced power. Now our customers have a choice. What do they do with that savings? Do they send it to the bottom line? Or do they look at the possibility of migrating to more green or more energy efficient power, making investments in solar panels, making investments in wind farms, or just upping the percentage of green power that they buy? The nice thing about this is you've got the initial benefit of just reducing power. That's every watt means less CO2. Then by freeing up that cost or that additional money, the investment in these additional green technologies can really amplify the benefit of your energy efficiency story. And that's what we like to show our customers, is that you can make even small steps add up very, very quickly, because you're basically doubling the impact for every watt you save when you go down this energy efficiency path.
Great. And then, I mean, getting to the promised land of, carbon negativity, that really depends though on finding a renewable energy source, one thing really, and which is getting easier in some places and still a problem in other places, but that's part of the strategy. And then another part of the strategy would be finding smart ways to actually use the heat generated by data centers and convert it into the things and Can you talk a little bit about that?
Yeah, this is a fun one. This is actually a fun one. So for anyone that's ever walked behind a rack in the data center, you know it is hot back and behind these racks. It's like, feels like sometimes your face will melt. It's so hot. Now the devices themselves, they don't care. They're designed to work those temperatures. But all that waste heat, traditionally in a data center, we treat it as a waste product, something that has to be dealt with, just like a landfill. If we can find a way to harness that heat and harness that energy and reuse it in some other fashion, it is the ultimate form of recycling. Now, with our liquid cooling designs, we run our servers without chilling that water. That water is hot when it comes into the servers. When it leaves the servers, it's even hotter. And it's a very small flow of water that goes through there. And the liquid is very portable, meaning I can pump it from point A to point B, and I can reutilize it. We have several customers around the world that are taking advantage of that heat and using it for other purposes. They're basically recycling it. So, back in the 60s, we didn't recycle glass or we didn't recycle aluminum. Now we recycle the majority of that stuff around the planet. My hope is that liquid cooling can help us usher in an area where we're able to treat that waste heat in the data center as a viable product that actually has use and value.
Wow. And how have you seen it used in that way?
Yeah, I'll give you a couple of great examples. So you could take a very fun example, which is I'm at a university. I've got this supercomputer running, or a data center running. The heat effluent from that system could be pumped in and heat a pool. So generally, if you're in a cold climate and you've got a heated swimming pool, we're using electricity to heat that pool. I can replace that electricity by using the hot water effluent from the systems and basically transfer that heat into the pool. So that's a great use case. We've got a customer in Munich, Germany called LRZ. They've been basically recycling the heat from the data center inside the data center. They actually use it in a reaction called an adsorption chiller, and it actually turns hot liquid into cold water that can be reused for cooling their storage and networking devices. So they're actually making use of it inside the data center itself and just converting that energy from the form of heat to use it to drive a reaction that actually makes cold water for them. So it's really a unique and interesting a design that they've got.
Yeah, wow. Okay, well, one last one, and then we'll wrap it up because it's been fascinating. Going out in the world, you have companies are now very aware of this problem, and they're making moves to address this. This is they're on the journey.
Yes, a lot of customers are making this journey, and we're seeing it now more than ever before. Customers starting to ask questions around sustainability as they're procuring IT. That's something we have not seen that much in the past. They want to know how the gear is manufactured, how it was shipped, and also the sustainability impacts of running the gear over time. So I welcome that. I think it's a great thing that people are starting to wake up that this is something that they can actually make a big impact on. So it's a very positive thing.
Yeah, that's great. Thanks, Scott, for your time today and for sharing your thoughts. If you enjoyed the session, please do check out other episodes of Wired Briefings at wired.co.uk. And thank you to everyone for watching the session. Stay well, and we'll see you soon.